Okay, so you guys are welcome. This is Darko Lab, and this is all about AI Bootcamp. And in our AI Bootcamp, first we are mastering Python. Don't forget, this is the Python platform where we learn, we build, we code, and we educate. So today you are welcome, and today we are looking at polymorphism. And basically, with your background understanding of what we already understand of inheritance and object-oriented programming, then it means that with polymorphism, we just need to understand how it is applied and how we can demonstrate it in terms of what object-oriented programming. Okay, so the key thing is that polymorphism is a core concept in what object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. See, it provides a way to perform a single action in different forms. It is achieved through, it is achieved through, it is achieved through method overriding and interfaces. So we override the methods, and with the help of, as I said, abstract and all some things, you guys will understand all these things. Polymorphism is very simple. Methods overriding, more methods overriding itself and all that. Okay. So let's look at a typical example. Then based on the classes, objects, and inheritance, we look at how we can demonstrate polymorphism. Okay. So let me just put some code down. Sorry, this is markup. So let me go to code here. So let me put some code down. So within the code, we can then how we can use we can demonstrate polymorphism in this particular code. Okay. So let's say we have a class. We have a base class. Okay. Now you guys understand base class, so I don't need to worry myself. Base class is basically parent class, right? So class, let's say animal. Let me use the animal example so you guys get it, a clear understanding. So let's say our class animal, because we are not going to pass any, we are not going to pass any parameter or attribute. So let's just go straight away with our function. So let's say def. Remember yesterday I told you that if you are passing attributes or parameters to a particular base class, okay, or a particular child class, then you need what? The constructor. Don't forget this. You will need a constructor. But if you're not passing anything, any attributes and all that, but just the self, then you can go straight away with what? Defining your functions and all that. Okay? It's very important you guys understand these kind of things. These are the things you will not get when you are doing like the normal readings and all that. You understand? So when you get like one-on-one coaching like this or hands-on boot camps, then you get that kind of feel how these things works in programming. So dev speak. So let's say we are only passing ourselves, okay? Then here, let's return because we are not doing anything here. So let's return sound of. I just want to be fast so we can of the animal. Okay, so we can understand how the polymorphism works. Now, let me go to another one. Let me have a child class. Okay, so let me have a child class 1. Okay, and I'll say class dog, right? So inside my class dog, what will I pass? I'll pass the parent class, which is animal. Now you guys understand this. Now I'll say dev speak, which is self. Now dev speak, which is self. Let's return. Yeah, let's return the wolf. Okay, so we know who is wolf, right? Let's return this wolf. Now let's get another derived class. What should we be? Let's make it cat, right? So let's make another derived class 2, and then let's say class cat. Okay, inside the same thing, we pass the animal class. Then we say dev speak into bracket self again. See how it's simple, right? Then so you know cat does what? Meow, right? So we say meow. And how do I spell meow? How do I spell meow? Meow, meow. MEO. I think this should be good for us, right? Meow. All right. So you see, I'm just trying to make it a simple, a base class we have, which is a parent class. We have two derived classes, right? Now, now I can just create my objects, right? Um, create objects, okay? And with the help of objects, I can just pass, let's say dog is equal to the dog class, right? Oh, what did I do here? Sorry guys. Is equal to dog class, right? And then I can also say that what cat is equal to what cat class. See, this is a very simple thing we already know, right? We create our main class, we get our child classes to inherit from the main parent class and all that, right? This is something we know already, isn't it, guys? So what we need to do is we also know this how we can create the objects and all that, right? But what we are saying is that how would you be able to demonstrate polymorphism, whereby we are saying that it provides a way to perform a single action in different forms. It allows objects of different classes to be what treated as objects of a common superclass. You see? So this is the superclass, which is the parent class. These are different classes, okay? And these different classes, their objects are dog and cat. You see? And we are saying that it allows objects of different classes. So these are objects of different classes. This is the object dog, which is of this class, and then the cat is of this class, okay? Now, to be treated as objects of a common superclass. So we are going to treat these objects as common to this superclass. That's a simple thing of polymorphism. But how do we demonstrate this, right? And for you to demonstrate this is very simple. So what I'll do is, let me bring it here, come here, like this, okay? Then I will say function that demonstrate, just for you to understand. So let me add a comment. Function that demonstrate polymorphism. Polymorphism. Yes, I'm correct. So now, what we need to do is we want to have a function, okay? That function should demonstrate polymorphism. And all that I need to do is say, Death, what's the function name? The animal is supposed to speak, right? So we have animal here, and we have different types of animals which are child classes which will be inheriting the base class. Now the animal is supposed to speak, so let's make our function animal speak, animal underscore speak. You see how that is clear for you guys? Animal underscore speak. Now inside this animal underscore speak, all that we need to do is what? Pass what? An attribute. So let's make the attribute animal. Let's make it small letters so you guys understand. Now this becomes our attribute which we use to get the animal which is speaking. Okay, so now all that I need to do is come down here, and then I will just say animal dot. You remember this dot? What am I going to use? I'm going to use this speak. Hey, sorry, this speak here. You see, it's very simple. So animal dot, then I'll use the speak, which is of the parent of the superclass of what treated as object of a common superclass. Okay, so I'm just going to use the superclass function, which is what the speak. With this, I'll be able to know which animal is speaking, and it's very simple. So when I come here, I'll say speak, okay, into bracket, because it's a function or it's an instance method in our program, so we need to bring the bracket open and then the bracket close. You get the logic here, and it's very simple. And all that I need to do, because I want to know which animal is speaking, I need to bring what? The print what? Function. So I'll say print into bracket like this, and then outside the bracket, I close it like this. You see? And then all here, what I can do is, because I also want to know which animal is speaking and all that, I can just come here, and then I will do dog dot speak. Okay, sorry, dog dot speak into bracket this. Okay, the same I'll do cat. Sorry, today I didn't sleep well, so cat dot speak into bracket this. Okay, and then what I will do next is, because I want to know which animal is speaking, I'll then bring it animal underscore. It's just this one. This you bring this one. Okay, it's this one. So let me copy this entire thing here. It's just this one. Here, the reason why we are doing this, the key goal is you create the objects. So these are the objects, okay? These are the objects. Here is, these things are just to help in creating objects. When in real world case, when we look at real world, you see that it's connected to the platforms, the user interface and all that. So you don't do these things, but the key logic is here. This ones. This is what you do basically. Okay, guys? Yeah. So let me just paste. Did I paste? Yeah, I pasted. Okay. So animal underscore speak. You see? Animal underscore speak. So what animal is speaking? Instead of the animal, which this one, we need to know which animal. So we can pass anyone. We can say the dog for now. You see? And because I want to see everything, then I am going to use the print function. So print into bracket, then bracket close. Then I'll do same for this one, print into bracket, and then bracket close. You see, I'll do same for this one, print into bracket and then bracket close. You see, it's very simple. So we have, no, I don't need to even print it because it's already here. We done the print here. So I need to close this. Sorry. But we done the print here. So it will display it for us here with the help of this. So you see, once I run this program, okay, make sure your virtual environment is selected and make sure everything is properly aligned, indentations and all that. So you see guys, once we have this base class called animal, this child class which are derived classes 1 and 2, then we have the first of the two objects here created. With the help of this polymorphism, we can get what? These animals, the one saying woof, the one saying meow and all that. Okay, so let's run. So you see, the first one, dog does speak woof, and print cat does speak meow, animal underscore dog, which is woof. So with the help of this polymorphism, okay, we can get right from the what, the super class, this one, which is the parent class or base class, we can be able to determine which animal is what, is saying woof or is speaking or is talking. You understand? So this is a clear example of how polymorphism is what being handled. And it's very simple. You saw how I did it here. I demonstrated it here. Function that demonstrates polymorphism, and with the help of the super class, which is the base class, which we have it up there, I can pass any attribute here. This one can be any attribute name, but I wanted it to be consistent with what we are doing. That is why I made a small letter animal. So you know that we are looking for a particular animal who is speaking, and it's very simple. Here, this is just an object. This is basically will be connected to what? The UI, whereby when you fill the form, you get a display that, oh, this particular animal, or within your database you set so many settings where you can know that, okay, this particular animal is speaking and all that. So this is basically a simple scenario of how polymorphism is being what demonstrated. Okay, and it's very clear, it's very simple. Let's look at another one. So when I'm done, you have a question, then you can ask. Okay, let's look at another one. Let's look at a proper way, a high level, another way that we can also demonstrate. I did some notes. Let me look if I can get my notes. I want to find a better one for you guys. Okay, yeah, I remember now. So let's do this one. So basically, let me help with your understanding of this. So this is basically what method overriding. Okay, so when I come here, let me add a markdown here for you guys. So it's basically what we call method overriding. Okay, and in method overriding, we are looking at what? We are looking at method overriding allows a child, okay, it allows a child class to provide a specific implementation, okay, of a method, a method that of a method that a method that trying to recall so many things for you. A method that is already defined, yes, defined in its parent class. So that's why you see I already have a method here defined here. You see this method. That is why then with the help of this I can just use it anywhere. Okay. So I'm saying that this is basically method overriding in terms of polymorphism, and we are saying that method overriding allows a child class to provide a specific implementation of a method that is already defined in its what parent class. Okay, so this example you saw here is basically what method overriding, and I use polymorphism to demonstrate to you how we can override methods. That's why you're seeing functions that demonstrate polymorphism. Okay. Now let's look at another one whereby with this one we are going to look at the same thing, functions and methods. We're going to look at another different scenario. Okay. So let's say in a different context. So let's say let's have sorry let me make it polymorphism with functions. Why am I typing so bad today? Let's sleep with functions and methods. Okay, polymorphism with functions and methods. And let's look at a base class. So now, always I encourage you when you are coding, try to add comments so that anyone who is reviewing your code, any developer understands. And also use docstring. Remember, I taught you docstring way back in some of our days. So remember that. So let's say we have class. Let's go to shapes. So let's say class shape. Class shape. Okay. So class shape. Now let's go straight away. Depth area of a circle, right? Area node nothing. Let's pass it straight up here. Now we are going to say let's return the area of the circle. So you see how you guys understand it clear from the first one to this one. So let's return one. Area of the figure. Okay. Now let's have another one, another derived class. Okay. Derived class 1. So you see how I said this previously? It was animal. We had derived classes and we implemented our polymorphism. We created our objects. The same thing we are going to do here. So derived class. Let's make our class. One should be, let's say, rectangle, right? Area of the rectangle. So let's say now we pass the base shape. Okay. So now you guys understand these things. Shape. Then this time around, we need a rectangle. Sorry, I didn't spell it well. Now you guys understand a rectangle has some kind of what attributes, isn't it? What are some of the attributes? Yes, any of you guys here, Sameh, Mayor, and Rogers. What are some of the attributes that rectangle has? So you see the concept here. Shape, we define a parent class called shape, and with shape, this becomes our main base class, right? And now we want to have a child class which is basically the derived class. Now with this child class, we are saying that class rectangle, and because we want to inherit from the parent class, that is why you are seeing the shape here. Now because rectangle, which is a child class, has certain properties or attributes, then we need to pass some parameters. Get a logic here? So what are some of the attributes that rectangle has? Yes, those of you up here, or if you're in the comment section, you can type for me. Yes, what are some of the attributes? Those of you here, do you have any idea? Length, width, good. Rogers, length, width. Yeah. So let's for instance, let's use just two. So self, comma, let's use the width as we just said, comma, and then let's use the length. In place of the length, let's make it height for proper. Okay. Height. Okay. Now, so we know that, so you see how I did it, because it has attributes, I need to make it with the help of what? A constructor. Remember I told you this. Okay. Now all that I need to do is, now you understand the self dot what? Width. Okay, is equal to width. Yeah, width, comma, self dot what? Height, right? Is equal to what? Height. You see? And now all that I need to do is I'm done. We can get another one. What should be the next one? So we can get another function. I don't want to add an area here. We can get a function which will be proper programming. I don't want to add area here or anything there. So rectangle has width, height. Then I can have another one. Sorry, here, enter. We can have another function called, let's say, area. Okay, and within the area of the rectangle, I can say there's the self because we don't have any other attributes for this. Because the pi is just 3.142 or something. We can put it there directly or we can just leave it. So, which is basically the radius, which we will get it in anywhere. So let's say, sorry, I didn't bring this here. So let's say, let's return it. So let's return, what are we returning? So let's return the self dot the width, okay, the width of the rectangle times, you remember that when you want to get the area of the rectangle, is what? The width times what? Self dot what? The height, right? The spelling, sorry. T. Width, TH, yeah, this is correct, okay. Now, once we are done with this, let's have another derived class, okay? Derived class 2. Okay, now with this derived class, let's say is a circle. So let's say class circle. Okay, now with this circle, we can pass the shape as well, which is our base class here. We can then define a class which will be a constructor because the circle also has what? The radius, you know. So underscore init underscore into bracket, then we pass the self comma radius. See how it's done, guys? And these things, for you to be able to know the attributes, is simple. Depending on the problem or the project you are working on, you are able to define the various attributes for you to be used as your parameters to make your argument in this particular instance what method. Okay, all right. So now we have our class rectangle with height. We have our class in itself radius. Okay, now I close this one. I say self dot what radius is equal to what radius. Okay, very simple. Radius equal to radius. Okay, now what I need to do is I can have another function like how we did for the previous one, area. What should I do? How should I set this one? We have the area here, the area of the figure. We have this one here, good. We set this one. We can have another function in the circle. So we can call it depth area, right? Inside we just pass the self. Now we close this. Inside this we can return the function with the help of 3.14, which is a pi. You know the formula for the area of a circle, pi r squared. You guys remember pi r squared. So pi r squared is what we are returning it, which is 3.14 times what? Self dot the radius, okay, which is pi r. The r is the radius, and the radius is what? Squared. So the radius times again self dot what? Radius, because it's squared, right? So you see 3.14 times self dot radius times self dot radius, because the radius is squared. So pi, this is pi r squared. You see? Okay. Now we are done with this. Let's look at how we can implement or demonstrate polymorphism. This is normal. This is classes and objects and also inheritance. So this is clear. For this, you guys understand, right? So let's look at how we can demonstrate function that demonstrates polymorphism. Okay, so let's look at how a function can demonstrate polymorphism. So I'll just say def, and then I'll print the area of the of either the rectangle or the circle. So let me say print underscore area. Let me just give a function like this. So you get the concept. We just want to know which is the area of the circle or the area of the rectangle. That's it. So is that what's the area of the rectangle, or what's the area? And the area of the rectangle is what? Self dot width times self dot height. And area of the circle is what? Pi r squared, 3.14 times self dot radius times self dot radius, which is pi r squared. You see? So def print underscore area, then inside, what am I going to pass? Yes, at the comment section or here. What do you think we will pass here? I want to see if you understand the polymorphism. So what do you guys think we will pass in as our parameter to make our argument correct? Yes, anyone? At the comment section or here? Yes? Shape, correct. So shape, perfect. So we just pass our shape here, but because we already have this class, which is big, I'll just make it smaller like this. You see? So we know we are passing an attribute called what? Shape. Now, with this, I just do it like this. Okay. Then I can what? Say that what? Shape dot area. See? It's very simple. You see? So I'll just say shape dot area. But because I want to see which the area of that particular shape, like how we did for this, you see? So I'll use the print. So I'll come here, and then I'll put inside here, I will say print into bracket, you see? Because I want to see it, what will I do? I cannot specifically put them in quotation mark, so I'll use my F string. I'll use the F string like this, okay? And then I'll say the area is, and then here I'll put it like this, and then here I'll close it like this. Then I'll now bring my inside here, I'll bring this one, you see? Then now I'll finally close my bracket. You see? It's very simple. Okay? Then now, all that I need to do is just start to create my objects. So I can create my objects, okay? Create objects. Okay? I can say rectangle is equal to what? Rectangle. Inside I can pass, let's say 4,5. You see the concept, guys? And then I can say circle is equal to circle. Okay, inside the circle I can pass just the 3, the radius, because we already set the pi 3.14. You see, so we just need the radius. That's why I'm passing only 3. So you see, where's the circle? It only has one parameter, radius. You see, but when you come to the rectangle, it has 2 parameters or attributes, width and height. But the circle has only one parameter. That's why you are seeing 2 attributes or parameters here and 1 here. Take note. Alright. Now, I can run this. I can print just to see. Okay. Print underscore area into bracket. So what is it? We are printing the object, the rectangle. The same thing, print underscore area. What we are printing the object circle. So with this object circle, rectangle and circle, we get them from here, from the superclass, and with the help of polymorphism here, we can use it to get all that with the help of this polymorphism print underscore area here. You see, once I run this, I should see that okay, the area is this and then the area is this for each. So I can even specify for each. Okay, so let's run this. So you see the area is 20. That is for circle. So let me do this. Let me comment this out. Okay, and let me comment this out. So let me comment this out. First, let's run this. So you see the area is 20, which means the area of the rectangle is what? 20. Now if I uncomment like this, now we get all the 2. Area for the circle is 28 point blah blah blah. And that's how it works. And with this, it happens quickly at the background of the programming, and you get the feel of all that. Okay? Yes. Now let's look at one last concept. Which should I teach? Should I teach abstract? Abstract. No, I don't want to teach abstract, else it might confuse you guys. So we will look at abstract main in our object-oriented programming. Okay. Okay. So yes, I'm done for the day. If you have any question, you can request, you can add it at the comment section, or you can follow me, subscribe, and all that, and I'll be glad. Join our Discord. Our Discord is on. All the links are on my YouTube. When you go to darkolab.com, you should get all the links on my YouTube. Connect with us on the Discord, and then all the resources will be posted there for you and all that. Thank you.